dimensional analysis with density. So clearly we can see here we're going to be doing some dimensional analysis problems that also involve the density. So question number 1 right away says the density of air at ordinary atmospheric pressure and 25 degrees Celsius is 1.19 grams per liter. What is the mass in kilograms of the air in a room that measures 1,550 cubic feet? So just like every other problem we've done, we're going to start with the information that's given to us, 1,550 cubic feet. And we know that we have to do a conversion with that. And we'll notice right here that we see that there is a conversion with cubic feet. So cubic feet are on the top, so that means they have to go on the bottom. So 1 cubic foot goes on the bottom, and it's equal to 28.32 liters. So now our cubic feet have canceled, and now we need a conversion with liters. Okay, the only other conversion that's given to us is right here, and obviously there's no liters there. So when that happens, that means you've got to go back up to the problem and find another conversion that is just part of the problem that will have liters in it. And you'll notice that that's where the density comes in, is that the density of air is 1.19 grams per liter. So that means that for every 1.19 grams, that's equal to 1 liter. So since, again, liters are on the top here, I'm going to put 1 liter on the bottom. Don't put 1.19 liters, because, again, the 1.19 goes with the grams, not with the liters. So then I'm going to put 1.19 grams on the top. And then, again, my liters have canceled. And then again, the question is asking us for the mass in kilograms. Well, we've got grams now, so we're really close. Our last step is we've got grams on the top, so grams have to go on the bottom. So here's our last conversion. 1,000 grams is equal to 1 kilogram. Okay, so now we just use our calculator. We're going to go 1,550. We're going to multiply by 28.32. times 1.19, and then we're going to divide by 1,000 because it's on the bottom. Our grams have canceled. All we have left is kilograms. We know that we've done it correctly. And it looks like we've got 3 significant figures here, so our answer should be reported as 52.2 kilograms. Okay, so that means that, again, the mass of the air in the room, even though you don't even realize it, but there's air all around you right now that does have a mass. So if the room measures 1,550 feet, cubic feet, then you're going to have about 52 kilograms of air, in that space, which seems like a lot, but air does have a mass, and so that would be our mass. Okay, number 2 says brass is a metal alloy. So an alloy is just something that when you take 2 metals or 3 or more metals and melt them and then mix them together, you get an alloy. And so brass is a metal alloy of copper and zinc. So you take some copper and you melt it, you take some zinc and you melt it, and then you pour them together and you mix it up, and what do you get? You get brass. And brass has a density of 8.47 grams per cubic centimeter, and it costs $1.74 per pound. So again, even though we haven't gotten to the conversion part, the density here is probably a conversion that we're going to end up needing, and this is probably a conversion as well, that $1.74 per pound is something that might come into play here a little bit later. Okay, the question is, how much would 0.5248 gallons of brass cost? So again, let's not try to figure out the whole thing. Let's just start with what we know. We've got 0.5248 gallons. And I've got to convert my gallons to something. Here's a conversion here. I can convert 1 gallon to 3.7854 liters. My gallons cancel. And again, sometimes I do this too where, okay, I've used that conversion, let's get rid of it. And so once I've used it, now I know, okay, these are the other conversions that I have available to me. So liters, let's do a conversion with liters because that's what I have on top here is liters. And here's another conversion with liters. 1 liter equals 1,000 milliliters. And now my liters have canceled. So again, now I've used that conversion. And now let's kind of look here. The only other conversion that they give us is that 1 pound equals 454 grams. So now's the point where we go, oh, wait a minute. Now I have to go back up to the original problem and find hopefully a conversion that has milliliters in it, which, remember again, that a cubic centimeter is a milliliter. So this density says 8.47 grams per cubic centimeter. And again, that means that there's 8.47 grams in 1 cubic centimeter. So remember, if I have milliliters here, I can put milliliters down here, which again is the same thing as milliliters. So in 1 milliliter, there are 8.47 grams. And then my milliliters are going to cancel, and now I have grams. Okay, so now again, now I've used the density, so I can cross that out too. So now I've got grams. Again, they're asking about how something would cost. So I need money at the end. Oh, good thing they gave us something about money in the problem. Okay, but we've got grams first. So here's my conversion with grams. So I'm going to put 454 grams on the bottom, 1 pound on the top. Grams are going to cancel. And now I've used that one. So again, I'm just kind of looking around here. It looks like the only thing I have left is this $1.74 per pound. Oh, that means that again, kind of like density, every 1 pound costs $1.74. So that's a conversion we can use. So if I have pounds on the top here, 1 pound on the bottom equals $1.74. And now again, my pounds have canceled, and everything is canceled from the beginning all the way to the end, except for my dollar sign right here. So I'm going to take 0.5248, so that's a little bit more than half of a gallon. I'm going to multiply that by 3.7854. I'm going to multiply it by 1,000. I'm going to multiply it by 8.47. That's a point right there, 8.47. And now I'm going to divide by 454 and then multiply by 1.74. And it looks like here, how much would that cost? Again, looking at my math, it looks like it would cost about $64.49, rounding that 8 up to a 9 there. So $64.49 would be the cost. So if you went into the store, hey, I want to buy some brass. Okay, I need about a half gallon of brass. That's about what it would cost, would be about $64.50. Okay, last one. Liquid sulfur hexafluoride, which has a formula of SF6 right here. It's actually, sulfur hexafluoride is many times it's a gas. When you lower the temperature a little bit more, it actually is a gas. At 25 degrees, clearly it's a liquid because it says liquid. But when you lower the temperature of sulfur hexafluoride, if you raise the temperature, not lower it, sorry. If you raise the temperature of it, it will turn into a gas. And if you breathe it, it actually does the opposite of helium. Helium makes your voice get really, really high and squeaky. If you breathe in sulfur hexafluoride, because it is so dense compared to helium and compared to air, it actually makes your voice much deeper. So when you breathe it out like helium, it gives you a very deep voice rather than a high voice. Anyway, has nothing to do with the problem. Has a density of 1.329 grams per milliliter at 25 degrees Celsius. How many ounces of SF6 are there in 3 quarts of SF6? So again, just like always, 3.00 quarts is where we're starting. And all we're worried about right now is converting our quarts to something else. So here's a conversion. 4 quarts equals 1 gallon. Okay, and that is our conversion there. Quarts cancel. And now we want to go from gallons to something else. So again, we've used that conversion, so it's gone. Okay, here's a next conversion with gallons in it. 1 gallon, 3.7854 liters. So gallons cancel. I've used that conversion. It's gone. And now, again, I'm just going to keep going here. I know that liters, I got to cancel that next. So here's a conversion. 1 liter equals 1,000 milliliters. So 1 liter on the bottom, 1,000 milliliters on the top. So liters cancel. So that one's gone. And now we've got milliliters, and then again, I'm looking down here. I don't see anything with milliliters, so again, I'm going to come back to the problem. Hopefully there's something there, and yes, there is. 1.329 grams per milliliter. And again, that means that 1 milliliter has a mass of 1.329 grams. So again, 1 milliliter has a mass of 1.329 grams. There, my milliliters cancel. And now I have grams. So now I've used the density so that I can go ahead and get rid of that too. And remember, sometimes when you're doing these problems, a lot of times you stop and you go, wait a minute, I can't even remember what they're asking about. You're so busy doing your conversions that you kind of forget, what am I trying to get to? So remember, the question was how many ounces? So that's our final goal here, is to try to get ounces of SF6. So we've got grams now. So let's just keep going here. So here's another conversion with grams in it. 454 grams equals 1 pound. Grams cancel. And then my last step, it looks like, because I've got pounds on top, here's my last conversion here. 1 pound is equal to 16 ounces. So pounds cancel. I've now used that conversion. And again, I know that I have it set up correctly because everything cancels except for what they're asking me for. So now I'm going to take 3.00. And again, notice the way that I do this. Start from the left, just go left to right. So 3.00 divided by 4, because 4 is on the bottom, so I have to divide it, times 3.7854 times 1,000 times 1.329 times 454. Nope, excuse me. Made a mistake there. Times 1.329 divided by, not times, divided by 454, and then times 16. Gives me my final answer of, again, they want to know ounces. I have 3 significant figures to start with here. So that is 100, and it's 132.97, which is going to round to 133 ounces. And that is my final answer.